Hi! Let's now move on to the second block of Module 4, Ancillary Services. In this second block, we'll be looking at payments for capacity and energy. To get started with, let me refresh your memory in terms of what power and energy are. Power is an instantaneous quantity, which we express commonly in watt, and which we denote here P tau. On the right-hand side of this slide, you see for a given market time unit, a power generation trajectory for P tau between time t, the beginning of the market time unit, and t plus delta t, the end of the market time unit. Energy is then the result of integrating power generation over time. This is why it's expressed in watt-hour. Mathematically, that means that the energy between time t and time t plus delta t is the result of this integration between these two bounds of instantaneous power P tau over time tau. For the same example on the right-hand side, if we were to integrate this bold black power generation trajectory, we end up with this energy block in red, E from t to time t plus delta t. Let's now discuss capacity and reservation. Imagine that for a certain generation unit, over a market time unit, the maximum power that can be generated, that is available, is P max. This is represented here with this blue line. P max is this maximum power that can be made available. If you were to consider a conventional generation unit, P max corresponds to the nominal capacity of that unit. If you were to look at a wind farm or a solar power plant, for instance, P max is the available maximum power that can be produced, and then it is a function of the wind speed that is there or the solar irradiance plus some other parameters. So that means that for renewable energy generation, P max is not a constant value, which would be the nominal capacity or nameplate capacity of these generation units. Then from this P max, if we have capacity reservation, say C-res, that means that the maximum power that can be produced through this market time unit can only be P tau, which has to be less than P max minus C-res. Mathematically, this writes that as for all tau within the market time unit, P tau has to be less than P max minus C-res. In view of its definition, capacity reservation is also expressed in watt, as for power. When contracting ancillary services, such as those we are discussing in this module, the system operator implies capacity reservation. This capacity reservation means exclusivity in a way of this capacity being used for ancillary service provision. Note that we've introduced the concept here for upward regulation, but the same could be defined and applied for downward regulation, meaning that the available power to be generated has to be more than a certain level. You can imagine also that this kind of capacity reservation have an impact on what is the possibility to offer on the dead electricity market. For this example here, if a unit that has this maximum P max was directly going to the dead electricity market, it could supply, offer, and get paid for this whole amount of energy, which is P max times delta T. But now that there is some capacity reservation, the maximum that can be produced is this P tau here, which is P max minus C-res. And if we integrate over time, the block of energy that can be supplied is less than what could have been produced if no ancillary service was provided. Let's look at this through an example where we consider rogue trading, RT, which is a market participant that we've met in some other module. Over a certain market time unit, rogue trading can generate up to P max equal 100 megawatts. Now we have three illustrative cases where we look at downward and upward cases independently and then together. For these three illustrative cases, we'll look at the impact of providing upward, downward regulation on the ability to offer and subsequently on the revenues. In the first illustrative case, rogue trading gets a capacity reservation of 10 megawatt for upward regulation. That means that it can then only offer between 0 and 90 megawatt hour on the day-ahead electricity market. Why 90 megawatt hour? Since reserving 10 megawatt out of 100, the maximum power generation over this hour, this market time unit, is of 90 megawatts. 90 megawatt times an hour is 90 megawatt hour. Now say that capacity is reserved at a price of 100 kroner per megawatt, and that all energy is sold at a market clearing price of 200 kroner per megawatt hour. All energy sold means that rogue trading supplies the 90 megawatt hours through the day-ahead electricity market. The resulting revenue is composed of a capacity payment of 10 times 100, 10 megawatt times 100 kroner per megawatt, plus an energy payment of 90 megawatt hour times 200 kroner per megawatt hour. Overall, it's 19,000 kroner. Now, a case with downward regulation. Same example, rogue trading gets now a capacity reservation of 10 megawatt. Why is this minimum 10? Since rogue trading is promising to be able to go down in terms of power generation by up to 10 megawatt, it has to produce at least 10 megawatt over this market time unit. Producing at least 10 megawatt times 1 hour means producing at least 10 megawatt hour. Say now that capacity is reserved at 100 kroner per megawatt and that all energy is sold at a clearing price of 200 kroner per megawatt hour. The resulting revenue will be again composed by a capacity payment of 10 times 100, 10 megawatt of capacity reservation times a price of 100 kroner per megawatt, plus an energy payment for all the energy produced, 100 times 200. The overall amount is 21,000 kroner. Finally, a last illustrative case, consider that rogue trading gets a capacity reservation of 10 megawatt for upward regulation and 20 megawatt for downward regulation. Eventually, that means it can only offer between 20 and 90 megawatt hour. The reasoning is the same. 90 megawatt hour since it has to reserve 10 megawatt at the top. So instead of being able to produce up to 100 megawatt, it can only produce up to 90 megawatt. Times 1 hour is 90 megawatt hour. The 20 megawatt for downward regulation means that the power generation has to be at least 20 megawatt for this market time unit. 20 megawatt times an hour is 20 megawatt hour. Now say that capacity is reserved at a price of 100 kroner per megawatt and that all energy is sold at a clearing price of 200 kroner per megawatt hour. The resulting revenue is then composed of a capacity payment for the two sides, upward and downward, so 30 times 100, and then an energy payment for 90 megawatt hours if all energy is contracted, times 200. This overall revenue is now of 20,000 kroner. I would like to invite you now to use the self-assessment quiz to check your understanding.